Okay, energy assignment at level 3, number 1. Ralph the monkey. All right. So we have 2 different levels. We have you hanging on a rope. And the idea is that Ralph, your monkey, is going to run, grab onto you, and then the 2 of you are going to swing up in an arc to the top of this rope, or the top of this cliff. The angle given when you reach that point is 30 degrees. Okay, so the trouble here is, I think for some people, is figuring out the change in height. So what I'm going to do is I'm going to redraw that triangle. Okay, here is the rope down, here is the rope going up. This is the curved path that you would take, and this is your 30 degrees. And of course what we need to figure out is we have this height and this height, so we're trying to figure out the difference between these two, h. So to do that, we kind of need to play with triangles, all right? So what we can do is we can draw a triangle here, and then we can use whatever math we can think of. Remember, the black triangle is isosceles, right? Because the rope is the same length, obviously, on both black lines. So that means that all the angles have to add to 180, but they have to be the same angle on either side. So that would be, if you subtract 30 from 180, you get 150, and then half of 150 is 75. So this would be a 75 degree angle here and a 75 degree angle here. And then, of course, we can use our complementary angle theorem. These 2 angles, 75 plus something, has to add up to 90. So that would have to be a 15 degree angle right there. And we know the length of the rope, I believe. So we have to play with 14 meter vine. Here we go. So 14 meters, 14 meters. So what you got to do is you got to do a little bit of triangle math first. You're going to need to figure out, using a cosine law in the black triangle, and you're going to have to get a value for the line right here. And then once you're done that, you're going to have to use a sine law or a cosine law. I think sine law would be better, to then figure out, using the bottom red triangle, the line over here. So a couple of triangle businesses before you can actually get to the meat of the question. Once you get to there, and you know what that height is, right? So height is now a known number. Then we can look at the collision. Now we're kind of working backwards in this one because we don't know Ralph's speed, right? So the first part of the collision, here's what's important for you to remember. If I go back to the original picture, the first part of the motion, in other words, from here to here, when Ralph runs and then hits you, that's going to have to be governed by momentum, a momentum equation, because we know that momentum is always conserved, but we're not sure if in this collision the kinetic energy would be conserved. And we can kind of guess it wouldn't, because there'd be other waste energy. There would be noises and things that would happen when you thumped into Ralph as he hit you. So momentum is going to tell us what the speed, the V2 of the momentum equation is the speed immediately after the collision, but before you begin to swing up. Okay, so the momentum tells us the relationship between whatever speed you and Ralph have at the moment you begin to swing and Ralph's original speed. But the other part of the equation is this part, which is the swinging up. And this is one where we can do an energy equation, because it's just swinging. There's no collision. The collision's already happened, right? This V2 that we have here is after the collision. And so that means we can do EK1, EG1. But essentially, we're going to do the total in position 1 equals the total in position 2 for that. So the question is, where do we start? Well, in this question, because V1 is not given, we can't start with the green. We have to start with the red and work backwards. So you're going to start with your first step is going to be to do the total energy in position 1 and the total energy in position 2 equals. Now, the total energy in position 1 is the energy associated with this position, position 1. And the energy in position 2 is associated with this when you get to the top of the cliff. So, what's associated with position 1? Well, we can write down position 1. There's not going to be any gravitational energy because we're at the bottom of the swing, right? And because here we're not talking about satellites or going off into far away from Earth. This is still very much a near the Earth surface situation, so we can still use MGH in this case. So what's happening is you're being given a lot of kinetic energy from the collision with Ralph, but then later you are going to swing up. When you get up to the top of your swing, you're going to stop, right? That's the highest point in the swing. So there, your EK would drop to 0, but your EG will be now the change in your height. So we have a 1/2 mv squared and an mgh. The mgh is easy because that's going to be the h you figured out with all that triangle stuff, the change in the height. And the v here is going to be the v prime after the collision, right? Go back to the picture. This speed right here is the speed right after Ralph slams into you. So we can work this backwards and figure out what that speed has to be. Go ahead and do that. And then once you're done that, you can set up your momentum equation, the total momentum before equals the total momentum after. And here you've got the mass of Ralph and the mass of you. Well, you're not moving initially. So initially it's just Ralph's mass and Ralph's velocity. And then afterwards you have the case where you and Ralph are stuck together. So both of your masses, Ralph's plus the mass of you, are moving with that V1 prime after the collision. And you can see where this number is going to go in there. And then you're going to work this backwards and you're going to solve for Ralph's initial speed. Okay, so the hard part, I think, was this angle business, but you should be able to figure out what that green line right there is